Okay, hi. So my name is Aivars, and shortly about me, I used to work for a software vendor writing software in C++, so more than 18 years. And the software was used by tens of banks around the world. And main thing was that we didn't have access to the client system, so everything we had to debug the software was asking for specific log files or asking clients to execute specific commands. So that's one part how I got some of the skills. And now I work for another company, so luckily I do not have to ask for logs, but I still do not have access to production systems, so I can't use debugger as you normally would. And then I also do a lot of different projects and some cybersecurity stuff, and this all comes handy. But I have to start with a disclaimer. So I do not want you to get the idea that every project I touch is a complete disaster. However, if we get a single 500, then I will go and will have to investigate that. I will lose sleep and I will feel miserable while doing that. So, and it continues until I solve the problem. So let's start with some basic things. So there's this. If you know Brendan Gregg, he has these tiny books about observability of Linux. But he mostly comes at it from the performance tuning side. But however, a lot of tools mentioned here can be used to understand what the system is actually doing. And I will mention some of them as well. But first, let's do something without any tools. So there's this process file system every Linux has. And we think of Unix, so typical association is that everything is a file in Unix. However, processes as a files appeared first in the version 8 of Unix, and it's around 1984, so it didn't start as everything is a file. So the most interesting piece of information there is the environment of the process. So it's these numbers are the process ID, and then /environment is the file that contains all environment variables of the process. However, these are stored in the C-style strings, so it means there's terminating binary 0 for each string. So what I typically do, I use the translation utility to replace binary zeros with new lines, and then I get access to the full environment. And this is really, really handy because if you are running your software in Kubernetes and you are using some, let's say, Helm charts, some shell scripts, Python runners, then it's very hard to figure out what exact variables will end up in your process. So this is where I go when I need to see how to log into the database. There is the password and typically the host and the port of the database. Also, all your API keys are there. So if I want to investigate something, I go there and find all the credentials without asking access to Vault or something else. The next very interesting folder is called FD. It stands for file descriptors, and under there you have all files that the process has opened. And since everything is a file, then the first three are actually the console that I have connected to. There are some sockets, which are also files. There are some real files. There are some event polling kind of pseudo files, but they are there. So how can we use this folder? The typical use case is restoring deleted log files. And for the purpose of demonstration, I have a simple Python script that is logging something to the file every second or so. And over the time, it has produced something like 9, close to 10 gigabytes of logs. And a lot of people, when they see a large log file or they are running out of space, they go and delete the logs. However, there's a big surprise. The space is actually not reclaimed. It's still used. So why is it happening like that? It's because Historically, Unix doesn't have a remove syscall. It intentionally is called unlink, and what unlink does, it simply removes the file name from the directory. The whole content stays there until the open file count drops to 0, and then everything is removed implicitly. So when you call unlink explicitly, asking it to remove it, it will not remove it if the file is opened by some process. And so this typically happens. So when there were some problems setting up log file rotations, so the process is running, but the log files are not being written to. So how do I find this? Is either you know the process ID and then you list this FD folder and you see that some files have this deleted at the end of the name, or I can grep for all deleted files in my system, and then I get the process ID, which process is holding that file. So if my intention was to reclaim the disk space, then I just kill this process and the disk space will be reclaimed. So most of the time I'm interested in what's happening with the system. So there are two options. I can use tail -f. So just on this file descriptor, just as it was a regular file, and it will continue printing whatever the application is doing. The other option is to take a snapshot of the whole content of the file. However, you can do like copy or move or something like that. You have to cat. So what cat does, it reads the whole content and then stores it somewhere else, because this number 3 is actually a symbolic link. So copying would just copy the symbolic link. And using similar approach, I can find out which applications are using a specific file and keeping it open. So here I'm looking for Lua snip, and there are 4 Neo Vim processes using it. So that was like warm up. The most interesting part is tracing. So as I said, I couldn't use and I still can't use debugger in production. So we need to have a different solution, and for that we use strace. And so strace, what it does, it actually traces all the system calls that application is making. So it's calling the kernel. There are many good things about it. So I don't care in what language your application is written. Is it Golang? Is it Rust? Is it Python? Is it PHP? I can use strace on it, and I can find out what your application is doing. And somehow, if I ask admins to run strace on some application, they are more welcoming to do that instead of like installing a debugger and typing some print comments in debugger. Another great thing is that it doesn't require root access. So if you want to trace your own processes, you can do it. And yeah, if I have root access, I would probably go for BPF trace because it provides more information. And my favorite thing is that it can also be installed without root access. If I do not have root access to the server, I can install it under my own user. And I have installed that even in a Kubernetes pod. So you just download 2 packages. It's one binary file, one library. You set up the library path and you run strace. So how do you run strace? Strace, so these are the typical use cases. I usually use something shorter. So -f tells to follow all processes that will be started and threads that will be started by the process. -ttt, it simply prints a very detailed timestamp. -o stores output to the file. -s sets a bit higher limit on the strings that this tracing prints. And then you can attach it to an existing process that is still running, or you can start a new Linux command under that. Yeah, so that's the main idea. So how does it look like from the running application? So here, it prints, you would say, a lot of garbage, but once you get used to it, you can see that there's actually send to, and it sends select distinct on lone _r. and then it receives something that contains request ID and probably some value like 204 or I don't know. But it returns some value. You can kind of make out that it's doing SQL queries. If you would go into details or have a slower application, you would see that actually each line consists of two parts. So there's the entering part, which prints the input parameters to a function. So here's the poll function. It prints the input parameters, and once the function returns, it prints the result. And in the same way, when we try to receive data from socket 12, file descriptor 12, it waits in this part, in the entering part, and then once it receives the data, it prints the exiting part with all the data is received and also the length of the data. And so if you haven't done much system programming, then this is a cheat sheet. So if you see ePoll, poll, select, pSelect, so it's basically doing socket multiplexing. So it's waiting on multiple sockets for some incoming data or incoming connections. And this is a fine state where you see your application hanging. You shouldn't see it hanging on write or send to. So these should typically be very, very fast. There are some conditions where it might block, but then the system is under very bad conditions. So if the application is hanging on the entering part of accept, this is also fine depending on how your application is implemented. So I would say I don't see many problems there. However, if it is hanging on the connect, entering part of connect, so it means that the application is not implementing timeouts. And I gave this talk 3 weeks ago, and 2 weeks ago, Sentry fixed the bug. So when application was experiencing network issues and it was trying to report exception to Sentry, it could hang up forever because Sentry didn't implement timeouts. And similar to connect, if the application is hanging in receive from, read, it means it's waiting for data. And again, timeouts are not implemented. And this is probably either you forgot to set it up in the configuration parameters or application doesn't do it at all. Wait for, it's typically waiting for termination of child processes. And the next interesting one is Vutex. So this is basically waiting on a lock. And if you are interested more, then there's this fantastic site with Linux syscall table. So it has syscall numbers, names, and it links directly to manual pages of the syscalls, so you can read more about what specifically your application is doing. And another interesting part of strace is printed right when you start the application. So right when you start the strace. So here it says that the application actually has 3 threads, and then it prints state of each thread of application. And then it follows, so the 298, it keeps working, but the 2 other threads are actually blocked, so they are waiting on Vutex. And if you look, the first parameter of Vutex is the address of Vutex, so these are waiting on 2 different Vutexes, mutexes, and it means it has a deadlock. So if the address would be the same, it most likely they are just waiting for somebody to release the lock. In this case, it's a deadlock. And now the story time, I will have several of these. So we had application that was performing slowly, and typically the tasks that should be completed in like 10 minutes, they were not completed for an hour or more. So what we did, connected to the server, and the CPU load was okay for that application. It was kind of high for arbitrary application, but for that one was fine. But they had high IO load, so I used at that time Nmon to monitor that. Or if you, but that's kind of old tool. There's IOstat that should come with every Linux, and if you pass -X, then the last column will say how much of the IO capacity you are actually using. It will print percentage, and in that case it was around 80. So we found out PID of one of the background tasks and run strace on it. And what it was doing, it was statting. So stat is basically checking the file permissions, file size of a specific file, and it was looking up a lot of files in this /storage folder. That gave us a clue, because I forgot to tell that application log files looked fine. It was doing at the same rate it was doing it before. What was the root cause was that we had this custom file field with some extensions that it was looking for a file in several folders, kind of in active folder and backup folder. And by accident, the background task was simply loading more objects that needed, and therefore it caused more file checks. However, it shouldn't be that bad. So the question is why the I/O load was so high, because we are just checking if the file exists and what is the size. And just to save time, so we had migrated to new servers with storage attached networks. And there's so this command checks typical performance of the database, because it's 8K blocks. So file systems work with 4K. I do not have numbers for the file system metrics, but I have preserved this kind of database metric. So 8K blocks. And so the new ones were doing something like 28 megabytes per second. And the old one, Hetzner machine that we had used for years before that, it was pushing around 12 times more than that. And yeah, so it was really a hardware issue or virtualization issue. So this got some improvement since then, but one thing to take away is that it might be also that the hardware is at fault, not your software. So then networks, we have a lot of integrations with other companies, and typically what happens is that we agree which IPs we will use, and then both parties open holes in their firewalls for those IPs, and then they say, okay, you are good to go, you start the application, but it's not working. And then you ask, network admins, are you sure that you have correctly set it up? Yes, of course, it's a problem with your application. And then you as an application developer have to prove that it's something in a network, and you have to do it without networking tools. And if you Google for that, Google will say that you can use ping and traceroute to do that, but most admins typically cut off ICMP and UDP traffic, so those tools do not work. So what to do? So there's this wonderful tool called TCP trace. So it tries to establish connections just like your application would. But it uses this time to live to print a nice network, trace. So it connects to, and since it works with TCP, it also requires a specific port. So this is I try to obfuscate some parts of it, but basically you run TCP trace route on some HTTPS port. You get a path that the packets took to reach that, and then you show this to your admin, and then they will say, oh, why are the connections going out through incorrect IP? Well, I don't know, figure it out. So that's a good way how to provide information to them, and then they fix it. So story time. So we were building one of the first services using Kafka, and we had a setup where we consume a lot of CDC events. So Debezium was capturing changes from Postgres database, and then we were enriching those messages and producing new events. And somehow it worked only at around 20 events per second. So some of people told that, oh, well, that's fine because Kafka can scale, and we can scale it up to reach the numbers we need. For me, it somehow seemed that it's a bit too little. So I got some time to go and investigate what's happening. So first, I turned on the logs for the Kafka library. So it said that, it really took 43.15 milliseconds to produce a message. Then I did a TCP traceroute for this hosted Kafka. and kind of network times were around the single millisecond, so the network latency was not an issue. So and then I resorted to my favorite one, which is strace. And when I looked at strace, so I highlighted 2 timestamps. So it's when the poll, so kind of socket multiplexing call started and when it ended. And so it means that it waited around 47 milliseconds for a response from Kafka. So then I understood that, okay, so it's not a problem with our application. And I had a hunch, but I didn't expect that Kafka was that bad. So whenever you can't get past in your networking application past 40 milliseconds or push more than 25 events per second. So this is a magic number that is usually blamed on Nagel's algorithm. So therefore, all your sockets should set this TCP no delay that disables Nagel's algorithm. However, the real issue is the interaction between Nagel's algorithm and delay DAC. And I think that Nagel algorithm makes more sense. I would find a way to drop the delay DACs, but that's me. So we actually reported an issue to Kafka library, and it's been around 2 years. So I got a comment, seems nice. It's still not merged. So there's a non-default configuration parameter you have to set to disable this Nagel's algorithm. And there are some more links, interesting to read. And we have another story. So this time it's a timeout issue. So the application was doing kind of some quant stuff, calculating stuff for quants. And the application itself was written in Python, and it was doing all the heavy work. There was a Scala client that was calling the Python application. It was running in Kubernetes, and well, a single HTTP request took a lot of time to complete, depending on how much data you posted to it. Then the time changed. So the problem was that if you post 1, 2, 3 rows, then it takes like seconds, 1 minute, 2 minutes, 3 minutes, 5 minutes, and then 2+ hours, and you get an error. So of course it worked in the development environment. It worked on the developer machines. It didn't work in Kubernetes. However, on Kubernetes, it worked with if you used curl to call the endpoint. So whenever you have some networking issues, you have to ask, what would curl do? Because this is the golden standard of network programming. So if you look at the strace of it, first it says TCP no delay. So perfect, curl knows it. But then it says some keep alive and keep idle and keep interval. So what are those? Those are keep alive settings. And why does the curl do that? Because Linux defaults are really, really bad. So in Linux defaults, it says that it will send first keep alive packet after 2 hours of inactivity. And then it will keep doing it 9 times with 75-second interval. That's too bad. And you might say, oh, well, that's Scala stuff. Well, no, Python is not better. So one thing Python does better than even Kafka does, it sets this TCP no delay, even in some crappy HTTP library, sorry. It's just HTTP library. It's not low latency, high performance Kafka stuff, but it sets no delay, but it doesn't set those keep alives. So, and then again, I mean, it's HTTP. You shouldn't be doing requests that take minutes over it. But the thing is, we all have long living connections. Oh, sorry, first let. So what was happening, that was some firewall and gateway was dropping connections after 5 minutes of inactivity. I don't know where it was. It was hosted hosted Kubernetes, no idea. But the client didn't receive FIN packet. It means it didn't know that the connection was dropped. The server didn't know that connection was dropped, and it continued to work and tried to send response. And then the client starts sending keep alive after 2 hours, and then minutes later it understands that, oh, connection is timed out. So we have long-lived connections elsewhere. So typically it's database connections that we try to keep alive. So there are settings. These are the Postgres settings. And please do set them, because Linux ones are bad. And then, so my favorite approach, but this is me, I like the brute force. So there's a library that you can preload, and it overrides all socket creation and automatically sets these keep alive values to some reasonable ones. So with that, you can solve it for Python, PHP, Scala, whatever. So this is what I use to fix the Scala issue. And once you think, okay, so now I'm good, but your application is running on Kubernetes, and the admins decided that service meshes are nice, and service mesh layer 4 proxies are even nicer. So what happens is that, so layer 4 means that it will intercept the real connection, so you physically connect to this proxy, and between application and proxy you have the keep alives, and then the proxy creates a new connection to the database, and it doesn't set the keep alives. So yeah, so we actually solved this by removing service mesh. Win-win. Yeah, so as a summary. So the process file system contains a lot of goodies. I showed just a few of them. There are many, many more, but it's probably a bit too low level and not for this talk. strace is a perfect debugger for any black box application. I do not care if your application is written in Python. Is it using clean architecture, clean code? Does it follow solid? Does it not? Is it complete spaghetti? Was it generated by AI? I can trace it with debugger. Then TCP traceroute. So again, a debugger for black box networking. Then remember to set timeouts for everything. And remember this 40 millisecond magic number. So it has been years and still there are companies posting, making posts every year that, oh, we solved our latency issues by setting TCP no delay to 1. So just keep in mind, then set up keep alive explicitly for your long-lived connections, and then compare disk I/O with whatever your database servers, cloud servers against your laptop. So that will give you a good benchmark. Sometimes I have written like SQL benchmarks to measure managed databases, and the spoiler alert, a lot of these are much worse than your laptop. So sometimes the issue is not with your application, but with the hardware of the cloud providers and their setup. So that's it. Thank you.
This was super interesting, so thank you for your talk. My question is, how many years of experience do you have, and how did you go to the Linux and WoW level stuff? Because it's usually people don't go there.
I'm old and I have been working more than 20 years in IT. So, and if you debug C++ applications, you get pretty early into that, because in C++, if you make multi-threading wrong, it crashes. If you get it wrong in Python, so maybe once a year you will have an issue. So.
Hey, did you have any problems with TLS or SSL connections as well for the Keep Alive stuff?
Yes.
Have you recommendations for tools for tracking memory, particularly shared memory buffers?
Shared memory as in System 5? Yeah?
Yeah. So we've any IPC memory. So we've server run out of memory, but it's not visible in processes. It's not VSS or any of the process tables. Don't see it in top, but the server runs out of memory.
Yeah, it's still under process file system, so as well as the IPC message queues. So that's my pet topic, IPC message queues. I like to use BPF trace, but it requires root access. So then you can trace those calls inside the kernel. But yeah, I understand where are you coming from. It's a tricky space. because if you modify that memory, you affect other processes. So, yeah.
Yeah, so we currently have an issue with one of our servers, and we're really struggling to figure that out. And one thing is that we really have trouble figuring out when the issue actually starts happening. So everything runs fine, and then it does not. So I'm wondering, is there any good solution to run strace in the background for some way to just figure out the time when something happens?
You can do it, but depending on so there is a standard package in Linux called audit-d, where you can specify which system calls you want to intercept, and it will store that to a specified log file. So that's probably kind of more, I would say, user-friendly. So I have set it up like just because something happened bad during backup. So I just needed to have like, well, backup process did these system calls around this time, so I can correlate things that happen. The other thing is, well, I would go for BPF trace if you have root access, because it has more information. But then, yeah, just to get the initial idea, I would use audit-d.
Thank you.